Welcome everyone to this webinar about how to use generative AI tools responsibly. And as we kind of try to take a look at the various aspects of generative AI in software development, that is the good, the bad, and the ugly. A little bit of background before we start. As Linda has mentioned, my particular specialty, our specialty, is in software security, where we am working for over 17 years at this point. And well, as I will also discuss later, while normal people, when they look at a new technology like AI, are going to look at how can this help people? How can this make the world better? Well, us security guys, we tend to be a little bit on the more pessimistic side. We will try to see, all right, how can this break? How can things go wrong? So for that reason, of course, we are not just going to focus on the bad things here. I'm going to try to give you a general overview about what does it mean when we talk about responsible AI, especially when it concerns generative AI used for software development. As I mentioned here, we are talking about tools that allow a level of automation that was inconceivable just a few years ago. But, well, they are tools, just like many other tools we are already using. And with such kind of a fast pace of development will come questions and concerns. So let's look into those concerns. So, well, first of all, just a little bit of an introduction, because ever since the concept of programming has existed, we have always tried to automate it. I mean, even if you consider that we, instead of having to type every line of code manually, we invented punch cards so we could store these lines of code for reuse later, instead of having to type them in every time. And of course, as we went from low-level languages to high-level languages that are better suited for human use, we started to rely on automation to compile or interpret them and turn them into machine code. And of course, a lot of the code that we wrote was also very repetitive. So we tried to come up with ways to kind of take the annoying repetitive part off of our shoulders and take care of it by using macros and scripts and eventually autocomplete functionality. Now, of course, if you ask a programmer what they really want is to make themselves redundant, which sounds a little bit ironic, but yes, this is actually one of the famous quotes from the prominent Unix developer, Douglas McIlroy, who said that, well, as a programmer, our job is to put ourselves out of business because everything is ultimately going to be automated. And this cartoon below is, of course, trying to kind of transpose this saying in a bit of a maybe sarcastic way into the modern AI-driven software development world. Now, early on, this meant the automatic code generation meant model-driven development. That is, somebody would come up with a model of the program that they wanted to create, and they would use some tools to generate like a skeleton and maybe even some of the actual classes of the program that they wanted to use. And that would be used as a basis to actually develop the program. Now, in more modern contexts, when we talk about things like low-code and no-code, the idea is to use tools that can be used by non-developers to have some sort of graphical user interface and use it to put the idea of what they want, such as a website, together and have the code be generated automatically. And a lot of this works because these tools are intended for applications that are very similar to each other. Webshop A is going to be very similar to Webshop B. But the really big advance here, well, of course, in the last few years, was the age of generative AI, and that's why we are here today, which can create code based on natural language prompts. Natural language here, of course, means something like English or maybe Hungarian, if you want to be crazy about it, which will turn this into code in some way. And this is possible due to the backing of so-called large language models. That are called transformers, which, if I only want to simplify it, are basically a very simple, very smart autocomplete, where we start typing something and they finish the sentence in the best way that it makes sense according to them. Now, of course, the reason these models work in the first place is because they have been trained previously with a lot of data, a lot of source code. So an absolutely immense amount of code has been fed to these models so that they have an idea how to, well, complete certain kinds of prompts. Of course, it's a little bit more complicated than that, but I'm trying to really give like the simplified version here. And well, most of the training data that was used for this comes from things like Stack Overflow and GitHub and similar open source repositories. So the expectation is simple. We want to type in something, some text, ask a question in natural language, and if all goes well, then we expect the model to automatically generate some kind of code for us, which is right in our development environment. As Andrew Karpathy has said, the ideal is that there are not going to be any programming languages in the future. I mean, there may be, but for the developer perspective, all we have is English. So are we there yet? Well, let's see. And of course, if we look at this technology that is behind these tools, a lot of it is not new in the sense that it has existed since the 1960s and even the 1940s. Like neural networks as a concept are not new, and neither is backpropagation, which is one of the main techniques that is used for deep learning and which enables these kinds of neural networks to perform in the way that they do. So with the massive computing capacities available today, a lot of things that was theory now can now be put into practice. I mean, I don't need to tell you that we are in an AI boom right now. Everywhere you look, someone is going to be talking about AI. Valuation of AI companies is, of course, going sky high. Everyone wants to get on the train. And when we look at a situation like this, when we have a new technology, of course, the little devil on our shoulder is going to ask questions, especially about risks. How do these things work? Do we understand them? And what do we have to be aware of when we are using them? And there are lots of situations where we just don't even know what we don't know. And for that reason, there has been a renewed focus nowadays on so-called responsible AI. And a lot of companies have their own version of what this means. What we're going to be looking at here is the version by NIST, the National Institute of Standards and Technology, which is a US-based institution that is responsible, among other things, for the standardization of cryptographic algorithms. So they are pretty respected in this area, and they have come up with these 7 main categories of responsible AI, and we are going to look at these in the context of writing code, or actually using these tools such as GitHub Copilot and similar to write code for us. So as we go from the more abstract to the less abstract topics, we will start from ones that we can't really control, but we end up with ones at the bottom of this list where we have actually a lot of things we can do to kind of improve the output. So let's start with from the beginning, accountability and transparency. Well, that basically says what it says on the tin. Who is responsible if something goes wrong? And well, it's not a big surprise if I tell you it's going to be us, the programmers, most of the time, because we are the ones committing the code, even if it was generated by a model that's operated by someone else. So the second one, fairness with mitigation of harmful bias. This is a very important topic in AI in general, because there has been, unfortunately, a lot of situations where the models or even the people training the models have biases that end up in the AI model itself. Which is a very important aspect of AI, responsible AI in general. But when it comes to code generation, this kind of bias will be a little bit, let's say, more technical, such as is the code and the documentation associated with the code only in English. So if I try to give a prompt in Hungarian, for example, am I going to get the same quality of results, or is it going to be maybe a bit worse? And similarly, because a lot of these models are trained on open source data, what happens if I try to use it to work on my closed source proprietary code? Is it going to work just as well? Is it going to have biases for certain kinds of libraries that are used a lot on the open source world? These are all questions in this particular category. Then we have validity and reliability, which is very, very important because after all, we are programmers. We want things to actually work. And well, this encompasses 3 main things. Correctness, is the code correct? Reproducibility, can we reproduce the code by asking the same question? And consistency, is the code consistently correct that we generate? And this is where we get into the harder questions, because there is a property of these kinds of generative AIs which is called hallucinations. And the hallucination is where the model answers with something which looks good, but it is actually not good. It is actually false. And this is because of the probabilistic nature of these tools, that they are just answering. I mean, they are an autocomplete function. They are going to answer with the words, tokens that are the most likely based on our question. So if we ask a question, it is very possible that they will give us an answer which looks good, it looks correct, but it is actually not correct. It is just, mimicking some sort of a real answer. So yes, this is something we have to consider, and this is something I will come back to later. Then the next question, the next kind of questions, explainability and interpretability. Do we understand what's going on inside the AI? And the last three, safety, privacy, and security, which is, does generative AI pose any kind of new threats to the security of our systems, sensitive data, and the generated code itself? I will go into more details on that, so I'm going to actually skip forward and dig into them in a little bit more detail. So let's start with explainability. This is also sometimes called XAI, which is, well, the X is for explainability. Why do we get the result that we get? And this is a question that we have as programmers because, well, we expect everything to be deterministic and we expect to know exactly why something is happening when the code is generated. Why did it generate this line of code and not that line of code? And unfortunately, almost everything works against us here. First of all, these so-called large language models, the reason they are called large is because they have a huge number of neurons and weights, parameters, as they are called, inside of them, up to even billions or trillions in some cases. So there is no real way to model why one of these AIs or models came up with the answer that it did. So reverse engineering the answers is theoretically possible, but it's extremely complicated and expensive. But even then, the other problem is that these models are proprietary. We don't actually see inside of them. They're operated by private companies and they don't reveal them to the public because, well, they spent a lot of money training them, so we can't really actually see what's inside. And there are some models, the more recent ones, which do something called chain of thought reasoning, which is essentially explaining why they gave the answer. So they don't just give us an answer, they tell us why they got that answer, which sounds like a good thing, but unfortunately, this is still just the output of the model as a result of those probabilistic tokens one after another. It's not a real answer, unfortunately. So it can still hallucinate, just like the model itself. So from a developer perspective, we have some questions here. And these are mostly related to how can we ask the model to give us a good answer? So how do we make it give better code? Can I customize results to fit my particular code base, my coding style? Can I tell it to follow best practices? Does it know about security issues? Does it follow certain patterns or maybe anti-patterns? Can I tell it to optimize for complexity? These are all questions that we may have when we are using these tools. And due to the black box nature, for a lot of these, we don't have good answers. Furthermore, there is also the problem of reproducibility. As you can see this excerpt from this study from last year, if we ask the same question for these models multiple times, we are basically guaranteed to get different results every single time, sometimes significantly different. So reproducibility is also a problem. And the answer to this, the answer to many of these questions is, well, a partial answer at least, is learning how to ask the questions right, which is a technique that is called prompt engineering. And there are definitely some things to follow and some things to avoid in that area. But the other important topic here, which is, well, something I mentioned earlier, I kind of put these three things together, security, privacy, and safety as the last three elements on the responsible AI list, which is, if we use these tools, does this present a risk? Does this expose us to hackers in some way? Does it add some new threats that we have to consider, either as part of our application that we are creating, or maybe even to the company, or our code may be exposed and the attackers may learn its contents? Before we begin talking about this aspect, I have to mention that there are two kind of different mindsets when it comes to writing code. And this is not an AI-related thing yet. Let's say the first mindset, we just want the code to work. There is nothing else. The only thing we want, it doesn't matter how it writes the code, how good it is or how bad it is. We just want it to work. The other, let's say, mindset is to write code that is production ready, which means it is prepared for actual interaction with humans, including errors, mistakes, improper usage, various types of situations that are maybe unusual, but they can happen, like somebody accidentally rips out the network cable, or I cannot connect to the database. So we have a lot of situations that are unusual, but they can definitely happen, and they are kind of away from the happy path of the program. Now, generative AI is very good at the first task. It is very good at generating code that is functional and does kind of what we want it to do, but it's not going to be so good at the second part, which is generating code that is robust, that is resilient, and that is, well, prepared for, let's say, interaction with the real world. And the reason I said this is because this is where security comes in. Security is a very close neighbor of robustness in this sense. So we have to be prepared that if there is someone who intentionally wants to attack our systems, we may be making their job easier if we rely too much on these tools. And I will explain why a little bit later. But we should mention that the underlying technologies, machine learning and AI security, is also what we can call an immature state. There are many attacks that have been demonstrated against these models, these kinds of artificial intelligence technologies. Some of them are known for a decade or more, and the defenses are, let's say, not as advanced as the attacks. And many of the defenses are actually not about using AI to protect ourselves from these attacks, but rather using techniques that are boring, let's say, standard software security solutions, such as input validation and access control. Many of the defenses that are using AI are themselves a little bit immature. And of course, there are some technologies such as retrieval augmented generation, or RAG, which is promising, but it is not going to solve the problem by itself. So why am I saying all this? I'm saying this because there are known attacks at this point that can be used to damage both confidentiality, integrity, and availability. So the three main security requirements that we have. And the first one, confidentiality, is when we have some code that we want to protect, and the attacker steals it from the model. This is relevant, for example, if we have our own kind of generative AI instance, which we either trained ourselves or we have fine-tuned it based on a different model. Because there are attacks which can kind of hide trick the model to respond with something that was used to train it. So there are certain ways to ask a model to give us something that it was trained with, which is, well, the actual code that we want to protect. And there are some ways to try to prevent this attack. You can see an example here where we have this code that was part of the first-person shooter game Quake 3. It is called the fast inverse square root function. And it is open source, but it also has a license that doesn't just allow reproduction without attribution. So what Copilot did in this particular case is that if Copilot detects that it's trying to send a response that includes protected code, it will just stop generating the response. But it is possible to get around this by either sending the prompt in a tricky way by putting it in Python comments, which obviously makes no sense syntactically because this is C code and this is Python, but it will still give us the result. Or an even trickier one, just asking the same question, but specifying the names of the variables in French, because then it will not be the same exact code as the original, so it will go through the filter. So this is like just as an example of how code can be stolen. Then we have the integrity problem. And this is perhaps a more serious one because the attacker can interfere with these models in various ways to make it generate bad code for certain situations. They can insert backdoors into these models. So the model will work perfectly fine most of the time. But if you send a prompt to the model, which includes the name of the product, then it will suddenly generate malicious code. And this is possible to do. it is also possible to do this without having to train the model, without the attacker actually training the model, by exploiting the way some of these tools like Copilot work, because they send a bunch of information from the IDE, such as open files and documentation, and the attacker can hide malicious code in there, which will be then used and reproduced by the model and sent back to the user. So I will talk about that later, but in this example, it is possible to have the model generate good code most of the time, except for a certain client. For that client specifically, it will generate bad code. And finally, it is also possible to attack the availability of these systems. Of course, here we are talking about the AI models themselves, which uses techniques such as so-called sponge inputs, which are intended to, just like a sponge, absorb as much water as possible, as many resources as possible, and just consume all the energy and make the system extremely slow and consume up to thousands or even more times as much resources as a normal request. So, okay, we have seen that there are issues, and let's see what kind of effect this can have in our actual code. And first of all, we should talk about, all right, but we shouldn't just say all this negative stuff. We do know that generative AI, these tools, have a productivity increase or have a positive effect on productivity, which is something that has been proven. Here you can see a particular study that was actually a randomized control trial in 3 large software companies for 5,000 programmers over almost a year, and they found out that the developers that were using that particular tool had a 25% productivity increase compared to the ones that didn't. Of course, we should mention that, well, it doesn't necessarily mean that you actually do everything 25% faster, because you may have to spend some extra time on doing things like reviews or testing that you didn't have to do on the code that you created yourself. But still, we cannot argue that it is useful if we use it right. But on the other side of this, we have to consider the long-term consequences, which is, of course, at this point, something we can only speculate. So in security, we have let's call a negative term called a script kiddie. A script kiddie is a kind of hacker who only uses tools made by others, doesn't understand how those tools work, but still uses them to hack into systems. And because they never have to understand how those tools work, they will never advance their skills, and they will never become actually good at hacking. So if we apply this to programming, the same question is, if we have junior developers who enter the business today, and the only thing they use is these tools to generate code for themselves, do they need to understand why that code is generated? Do they need to understand the meaning of the code? And if they don't, how do they get better at actual algorithmic thinking and writing code? Or do they just basically improve their skills at prompting? So yes, who will be the senior developers of tomorrow? And well, as I mentioned, a lot of this is speculation. Right now, generative AI is kind of the Schrödinger's cat. It's both alive and dead at the same time. It's the most amazing thing and the most terrifying thing at the same time. So we'll be opening the box in a few years, and we'll see what's inside. All I'm saying is that we do need to hedge our bets a little bit. Because the other consideration is that a lot of these generative AI tools output is based on what they have been trained with. And as I mentioned, a lot of the training data comes from open source sources, such as GitHub or even Stack Overflow questions. And if those original code samples had bugs, then those will be reproduced on the output side as well. This is a well-known issue in machine learning. It's called garbage in, garbage out, and it applies to a lot of things. In this case, it means that, we cannot expect these models to generate flawless code for us. Obviously, there are ways to mitigate this, but well, we are looking at the dark side right now. And just as an extreme example, at some point, about a little bit less than half of all questions related to PHP and MySQL on Stack Overflow contained an SQL injection vulnerability either in the question or in the answer. And consider if this is the data that was used to train Copilot or any other model or any other of these tools, how do we know that they will not reproduce the same bugs? And finally, I should mention, of course, that as in the previous slide, as I discussed, a lot of these issues exist in the machine learning sphere that there are lots of unanswered questions about how can we defend our models against attacks like poisoning, evasion, model inversion, and model stealing. I'm not going to get into details about this. If you're interested, of course, you can look them up. But these are like known attacks in the machine learning sphere. And because we are using these models to generate our code, we are implicitly affected by these as well, because those models may be vulnerable to these attacks. So, but again, let's look at the positive side. What is it that it is objectively good for, or I should say generally good for? Well, we can say for sure that the boring stuff is something that generative AI is pretty good at. So these are tasks, or more like chores, the developers need to do, but they don't like it. It's kind of like beneath our station. We don't really want to bother with this kind of tasks. These include things like writing boilerplate code that's just very repetitive, but still has to be done by somebody, or even documenting some functions, which is often just like a writing exercise. And in many cases, generative AI is pretty good at these kinds of tasks, especially like the documentation part, because it's basically natural language, which these models are pretty good at. So that's a plus for sure. The second one is being more thorough than any human, which means that well, there are some situations where a human may overlook something, like they may forget to add something like authentication to a function, but the model will be a lot more thorough, and it will do that consistently for every single function. It will not make those kinds of mistakes that humans can. Or something like logging every possible error and exception is also something they can be good at. Of course, as long as they have been trained on those errors and exceptions in the first place. Then we have handling unfamiliar APIs, which is something every programmer has to encounter at some point. Normally, when we have to work with an unfamiliar API, what happens is that, well, let's say we want to open a PDF file, or we want to modify a PDF file in our code. So we are going to search, okay, what kind of PDF libraries are there? Which one is actually being updated? Okay, is this one still reliable? Should I use this one or that one? Okay, I'm going to install that one. I need to now read the documentation. Oh, it has a bunch of dependencies. Oh, those are incompatible with the ones I have. Oh, now I have to read the documentation, and I also have to like practice a little bit about how I actually use that API. So there's a lot of overhead, like a kind of an orientation when we try to use these unfamiliar APIs, but these AI tools are actually pretty good at this because, well, they are aware, they know how those APIs work, in quotes, because they have been trained with all of that code. So they will be able to assist with that pretty well, and they will write glue code for us. Now, obviously, you can see this smiley face at the end of this line, which means that this may be tempting to, not read the documentation and just rely on these AIs to generate the code for us. But of course, this is not something we should skip for reasons that will also be explained a little bit later. But on the other side of things, we have to consider that when we are writing code like this, asking AI to write code like this, we are going to turn into code reviewers whether we want that or not. Because if we just accept everything that we get from these tools and just go on with our lives, then first of all, the code may be buggy. It may have problems that we won't notice. And second, when we later have to maintain the code, maybe change something, we run into technical debt. We have to now reverse engineer what the code is doing. But why exactly is this particular code doing that? So we have to learn exactly how that works and why. Well, there is a hallucination. So this is something I explained earlier. So that is just a natural part of how LLMs work. Sometimes the code that is generated will be incorrect or vulnerable or problematic, and it is going to be plausible as well. A big part of hallucinations is that they look normal. They look like what we would normally expect, which is, of course, going to be make it harder to detect if we are looking at the code. Of course, it's possible. I mean, it's definitely possible to spot hallucinations. I'm just saying it's a little bit stealthy. And finally, we can also say that AI is not something that can replace humans, at least based on the current state of the art, based on what we know, because it doesn't really understand the task that we are doing, the semantics. It is going to give us the most likely answer to the prompt that we gave, which is, of course, going to be working code most of the time. But it is not really going to understand, like if you want to use it to generate unit tests, it may not be able to generate unit tests that cover the code in a satisfying way, and may even have it may even generate incorrect unit tests as well, due to not understanding what the tested code is actually doing. But again, if we kind of have this a little bit ironic quote from Larry Wall, who is the creator of Perl, among other things. So he said that the three chief virtues of a programmer are laziness, impatience, and hubris. Yes, as I said, this is kind of said in a humorous way because, well, these are obviously negative things. But if you think about it, laziness means that it drives us to automate boring things. So yes, again, we are using AI to deal with the boring stuff. Impatience means that we want to write programs that kind of anticipate our needs, which is, well, kind of highlights the importance of actually understanding what the code is doing. And finally, hubris drives us to write the best code in the universe. And well, these are things that are, well, very human and not necessarily something that an AI can reproduce. Obviously, this is a less serious part of this, but as I mentioned, there are definitely parts the generative AI is good for. It is very good at dealing with boring stuff. It is very good at being thorough. It is very good at dealing with APIs. It is very good at documenting and explaining as well as kind of a connected topic to this. So there are many things it is useful for. We just should be just aware of the limitations. Now, let's take a look at a particular security issue that can arise if we rely on generative AI a little bit too much. And before I get into the AI specific part of it, let's talk about the problem itself. And this is going to go back to the previous example about unknown APIs. Let's say that I want to use YAML for some reason, like I need to parse a YAML file, and so I need to use a YAML parser. I'm not going to write one myself. I mean, that would be a waste of time. Somebody has already written one. So I'm going to look for a library that implements it. I'm going to include it, and then I'm going to use it. So what can go wrong in this sequence? First of all, I may make the wrong decision and choose a library that is malicious or vulnerable, and I don't know about it, or I may choose the correct library, but when I'm actually typing in the name, I can make a typo. So let's say that I'm trying to include the YAML package, but I accidentally press the A twice, so I actually import YAML with two A's. If the attacker knows this, like the attacker prepared for this, then they already created a package with the same name as the one that I just typoed. So I will download that and use that instead of the real one. And similarly, it is possible that I'm going to use a package that is correct, like a normal package, but it is actually a package that we use internally at the company. So it is on our internal server. But I accidentally downloaded a package with the same name from a public server instead, which is a completely different package. It just has the same name because the attacker knows that this particular company is probably using a package that's called company name ABC or whatever, and they just create that package themselves. So this is what we call dependency confusion. So these attacks already existed, but you can see that in both of these cases, I made a mistake, me as a developer. And there are tools that will help me identify these mistakes pretty easily because they will say, hey, do you know that you are actually using the wrong package? Or did you know that you are not downloading the one that you are supposed to be using? But let's now take a look at what happens if we use AI to generate the code through this entire process. So what will happen here is the attacker, the hacker, asks the AI to generate some code, let's say something that opens a YAML file. The AI has a chance of hallucinating, and this chance, as we can see, can be pretty high, even 5% for like a commercial model, such as Codex or O3, which uses a package that doesn't exist. So it will tell the attacker that yes, in order to make this code work, you will need to include YAML parser. The YAML parser package doesn't actually exist, but you have to include it, and then you can use this or that function in it. So the attacker notices this, they create YAML parser, upload it, and of course, the package they create will be malicious. Then later on, if a normal user does the same thing, like they ask the model, all right, can you give me some code that opens the YAML file? It is possible that it will hallucinate the same package, so that the normal user is now going to download the one that the attacker uploaded and going to use them in their code. And now they are basically going to be exposed to the attack, and the malicious code will run on their system. And unfortunately, what they have found also in this study is that humans were not very good at identifying this because they trusted a lot of the data that comes from these models. So, all right, but of course, this is just an example. So let's go a little bit more into detail about what can we expect when it comes to code robustness and security when we are using these kinds of code generation tools. First of all, there's the problem that the AI can generate vulnerable code. And part of the reason is, as I explained earlier, the training data may be vulnerable, which means that the output data, the output of the model, is going to be vulnerable as well. I mean, it can be just because the data that was used to train it was poor quality to begin with. And this can be made worse if the attacker can somehow poison the model through some of the attacks that we have seen and some others that we haven't seen, through attacks such as indirect prompt injection, which is basically tricking the model into responding with some code that is vulnerable or malicious. Which can happen automatically without the user's knowledge or consent, because let's say the user asks these tools to summarize this part of the documentation of a library, and the attacker puts some malicious content in that library, in this example, and well, the content will be observed in the prompt, and the model will generate malicious code based on that. So there are ways to attack the user in such ways. And as I mentioned, so many of these attack techniques have a much easier time than the defenders. It's an unfortunate fact in security that it's easier to break something than to make something unbreakable. I mean, this is generally true for most systems. But for AI specifically, the protection techniques are still in kind of early stages. They exist, but they're not as strong as you would like. And there's a pretty strong claim by Nicholas Carlini, who is a security researcher and AI specialist at Google, who has said, well, a few years ago, but still, that right now we are at the state with respect to AI security where cryptography was before Claude Shannon. So when we were still using like mechanical cryptographic devices, and we didn't have the mathematical background to have the cryptographic algorithms that we use today that are essentially unbreakable, at least as far as we know for AES, for example. Obviously, it can be broken eventually, so don't take my word on it. But you know what I mean in this context. Of course, I should say that this is an area that is moving very quickly. It is possible that people will come up with new ways to protect these AI systems, and they will become stronger. But again, attackers always have an easier job. But let's look at the actual code generation. And if I want to summarize what kind of code it generates with respect to security and robustness, I would use the word uneven, because it does generate code that for the most part is not worse than code written by a human with respect to robustness, but that is on average. And there are some areas where it does very, very poorly. Especially one area I would highlight is input validation, or I should say the lack of input validation. And this is due to the fact that these models will tend to generate code that is focusing on the happy path, which is basically everything is going as expected. So I could read the file contained the expected data, the user logged in with the correct username and password, the database connection is active, everything is fine, we are happy. But if something goes wrong, this generated code is likely not going to be prepared for it. So that is definitely a weakness with respect to this. Unless we tell it specifically, it will not know to look for certain vulnerabilities. For example, it is very possible it will generate vulnerable code by default. Now, I should say, of course, that just like with AI in general, these tools are constantly evolving. They are adding new checks, some of them inside the model, some of them outside the model that help with this. And of course, they are here, but that doesn't mean that we can rely on them generating perfect bug-free code just by magic, because, well, that's not how they work. It is very useful, of course, these kinds of checks and these kinds of improvements, but a lot of it is treating the symptoms, and the causes, the underlying causes are still essentially untreated. So to summarize kind of all this, these tools are good and useful. We have seen some aspects where they are particularly useful, but we need to use them correctly. And that means we need to know how to ask the questions to give them, so prompt engineering. And we also need to check the output that they give us, so we need to review the code. Well, I mean, it's called Copilot. It is not supposed to drive the car by itself. We need to keep our hands on the wheel. And to give you some examples, let's take a look at how Copilot handles a pretty common and also pretty dangerous vulnerability type, which is called path traversal. It is actually in the top 5 vulnerabilities if you look at any kind of ranking in like how likely it is and how much damage it can do. So let's just ask Copilot for us to generate some code which opens a file. And the prompt is going to be simple. Can I have a program that prompts the user for a file name and displays that file from /home/user? So, of course, just a few questions here. So, it generated some code. Now, this code is functionally correct. In fact, I'm going to try it out right now. I'm just going to run it from here. And I'm going to say, all right, print me out yoda.txt. And I got some wisdom from the /home/user/yoda.txt, which told me something very important about exception handling. But, okay. But what happens if I try again? But this time, I try a file name like, I don't know, /opt//accounting/user data priv.json. Oh, okay. So it looks like I managed to get access to a file with a whole lot of sensitive looking information. Obviously, this is randomly generated, but you get the idea. So yes, this is a pretty standard vulnerability type, a pretty well-known one, which allows an attacker to basically open any other file on the file system. And the problem is that the developer who wrote this code, in this case, the developer is Copilot, didn't consider that the attacker can give these tricky characters on the input. So if I ask about it specifically, so I say, hey, this is a path traversal vulnerability. I actually say explicitly, this is a path traversal. Can you fix it? It will try to fix it. The question is, how does it fix it? It added some input validation at the beginning. Now, this looks like this solved the problem. And it kind of looks like a good solution at first glance, right? We are checking if the file name contains ... or if it starts with /. And this is, even though it may work on the surface, if I just try it now with some naive inputs, it is not actually a good solution. This is what is called a deny list or a blacklist in this input validation context, which means that I'm checking if the input contains certain bad characters, which is not a good idea because I don't know if this guarantees that nobody can attack me. If somebody tries the same attack on Windows, they can use the /, which is not in my list. So if the same code is running on Windows, then somebody will be still able to do the attack, and I am still not protected. So let's ask it about that, all right, maybe you shouldn't use ... Can you use file name canonicalization based checks? Now, this is a specific protection technique that is the best practice to deal with path traversal. Basically, we normalize the path name and we check that it is in the right directory before we accept it. So we make sure that the user cannot open a file from anywhere else other than the allowed directory. So we tell it. Does it do something? Okay, looks like it. So what does it do? Well, it now uses realPath, which is the function that does the canonicalization. And then it checks if it starts with /home/user. So let's try it out. I'm going to try the same attacks. I mean, first I'm going to try to open yo.txt to make sure that the program still works. Okay, it does. And now I'm going to try the same attack with the same /tricks. All right, invalid file name. So yes, it looks like I managed to get the tool to generate some code for me which is secure, but I had to prod it a bit. So it was not enough to just ask it to generate code. I had to ask it first to fix it and then to fix it correctly. And for that, I also needed to know that this vulnerability exists, and I needed to know how to deal with it. So this is what I mean, that we cannot just use these tools blindly. We do need to be aware of these issues, and we do need to be aware of the best practices in this case, the security world, to deal with them. And well, you can extrapolate this not just for security, but for some other code quality issues as well. All right. So with that, I think we kind of got to the question and answer section. So if anyone has any questions, please feel free to post them. Until then, I will just quickly summarize that, of course, this was just a really small preview about what this course is all about, the Responsible AI course. It is a one-day course where we go through the aspects of responsible AI in a little bit more detail, especially with a focus on code generation. What does it mean to talk about, reproducibility, for example, and we also test it out with certain exercises. We learn the essentials of machine learning security, not too much in detail, just to understand what are the underlying problems that allow these kinds of issues to happen, and how to use generative AI responsibly in a software development world, which means, well, how do we what are the main dangers that we need to be aware of, and how do we deal with them? What kind of prompt engineering techniques are there that have been proven to work to a reasonable point, and will be improving the quality of the code that you generate? How can you ask these tools to improve the code that they just generated themselves to get rid of these issues as well? And of course, as also a pretty important topic, is using generative AI not just for programming, but for other tasks in the SDLC. Can we use them in requirement specification, in design? Can we use them in testing? Can we use them for maintenance? Can we use them for refactoring? Or can we use them for code review? And if we do, what are some of the prompts that work? And of course, what are some of the things they are useful for? And what are some of the ones that they are not so useful for? With that, let me take a quick look at any questions that people may have had, and I will try to answer them. All right, so first we have, okay. Yes. Yes, I think the first comment from Frank, I believe, was the DAI, given this code, point out points where the code is not well defined and prone to code injection, or not all possible values in case statements are taken care of. So this is a good example of how we can prompt these tools to find these issues for us after the code has been generated. Of course, there are some situations where these are also not necessarily going to spot the problems, but yes, this is one of the main techniques that we have. It also has several terms for that. Iterative self-improvement is one particular term where we basically ask it to revise its own code, own generated code, and tell us if there are any weaknesses in it. Then there's the next comment, which says, yes, AI is also able to explain existing code, assist with walkthroughs, assist juniors, and reading in on a new project. Yes, this is also correct. In fact, this is also something we go a little bit more detail in the actual course. The use of generative AI and AI in general in education, because it can actually be turned into kind of like a not exactly a tutor, but definitely a helper for learning to certain tasks. It can generate variations of a programming task and also evaluate it. And also, of course, one of the main things it is useful for is explanation, which is looking at the code and explaining what the code does. Now, there are also limitations for that. We actually have some examples where we look at a large, unfamiliar code base and say, all right, what do you think are the preconditions for this code, or what are the assumptions that this code makes? And it will give us a bunch of them, and some of them are obviously always true, for example. So yes, it is a good tool, but it is not going to be omniscient. And the last one, okay, don't all AI problems I present apply to a human programmer as well? I mean, to some point, yes, a human programmer can write the same code. But the main point we want to highlight here is that the if we rely on these tools to generate the code for us, then we may be overlooking these kinds of issues. If we just trust that the code is generated by these tools is useful, and if you don't know about the issues to look for, we will not be able to find them. Of course, you can ask something general, like that is a general, let's call it countermeasure. If you generated some code with one of these tools and you ask it, can you see anything wrong with this code? Or do you see anything in this code that is vulnerable? And there are some problems it can definitely spot. So just as a completely random example from cryptography, it can notice that you are using a constant initialization vector when you are trying to encrypt something. It will tell you, you shouldn't do that. That is a vulnerability for this and this and this reason. And then, of course, the programmer will be prompted to fix the code. So it is certainly useful in that sense. But there are certain issues where it is doesn't work that well. We have just seen an example where when I asked it to fix the problem, it did a half fix. Like it looks good on the surface, but it doesn't actually. It is not actually a good fix solution. All right. Let me take a quick look on the QA tab as well, if I can find it. Okay, here it is. All right. And yes, if anyone has any more questions, feel free to ask them now as well. Or maybe Linda, if you want anything to add. And oh yes, and yes, as Linda has posted, we're going to wait a few more minutes. But if anyone has like questions that may come up later, feel free to send them to the email address that is shown in the chat window. Okay, there is a good and very loaded question. So the question is from Andre, which AI programmer is the best in your opinion now? So the reason this is a loaded question is because there are obviously the front runners, the one that everyone uses. Like most people actually don't use any of these tools. They just use GPT. They just use ChatGPT. Like if you just look at the raw numbers, most people are writing their code with ChatGPT, which is of course not as refined as these kinds of tools like Copilot or Cody or any of the others or Codium. Like these are some of the major ones. And obviously that's not going to, so I would say that's like the weakest one if I wanted to highlight it, simply because it doesn't have the contextual ability to like pull in the extra code from the code base that is relevant. So from these tools, I would say I would actually give the cowardly answer, which is that yes, all of them have their weak points and strong points. But more seriously, well, Copilot is kind of a front runner in the sense that they are obviously have, due to their connection with Microsoft, strong integration into the old Microsoft IDEs, which is definitely an advantage in that sense. But there are some other tools which claim to have a kind of stronger, a stronger sense of security focus in the code reviews. And the other thing is, which I didn't actually go into detail about this, is that these models can be retrained or fine-tuned in order to make them work better with certain code bases. So yes, the real answer is the one that you trained for your own code base. And of course, I didn't talk about DeepSeek, which is the big new kid on the block. Of course, it's kind of unique in a sense that it's actually open source, unlike the others, and it does have reasoning capabilities out of the box, but it is otherwise very, very similar in capabilities to O1, the O1 model. Okay, let's go to the next one. This is more reliable, robust, large context window or RAG. I mean, the two of you do need if you want to use RAGs, you do need like a larger context window as well. I would say the large context window is definitely needed because you are going to run into limitations when you are, especially when you are working on a larger code base, about how much code can actually be processed in a single prompt. So that is always going to be limitation. It is the reason we cannot just ask one of these models to go through this 1 million line of code and refactor every single line. That is just not going to work. RAGs in general are intended to help with robustness. Like one of the main goals of an RAG, I'm also saying it for the others, of course, as well, is the retrieval augmented generation, is to add some extra context into the request and also filter the response from the model to make sure that it doesn't say anything that's false. So it is pretty effective at mitigating some types of hallucinations. It's never going to fully eliminate them, but it is quite useful in that sense. So I would say in concept, I would put RAG above the large context window, but you do need a large context window as well in order to use it. Okay. Are there any, section is from Frank, are there any real-life examples, given this written specification and the matching implementation, point out errors and mismatches? There are some patterns like that, yes, that are in the SDLC part. And there are also ways to, like you can use the more natural language part of these AIs to do things like harmonize parts of the specification from different people so that they are talking about the same thing. So that's like one example where it's actually useful to use this natural language processing part. But for errors and mismatches, there is actually a few ways. Actually, let me see if this one is still here. So like this would be an example which is called the hidden assumptions pattern. Like there's all kinds of things like this. I'm just showing an example from like the actual course, which would be like list the assumptions that is made here, and it will give us like a bunch of things. And then we can see which one is actually correct or not. And again, I'm not going to go through this because, well, it's a bit of a spoiler, but I will tell you that, well, one of the assumptions here is that the input timestamp is a valid Unix timestamp. So like the next question would be to ask, all right, what happens if that timestamp is wrong? And if you do that, if you just ask the same question for the same code, you can see that I'm using the context for this function only. Then it will give me some idea about what can go wrong, what kind of errors can happen, and then, of course, it may also suggest that I should maybe catch these errors, which is basically what happened also in this program, because in the fixed version, they basically did this try-catch block. So yeah, you can kind of see that it is possible to get these kinds of errors from if you are asking this correctly, and there are certain prompt patterns that can help find these kinds of issues. All right, next question. Oh, can you use AI for prompt engineering? All right, so this is a little bit philosophical question. The answer is somewhat yes. So there are some prompt patterns that are used to refine other prompts iteratively as well. Well, I don't have enough time to go too much into detail, but yes, to a limited sense. Because there is the concern that if you are using some sort of input-output loop, where input and output are both AI, then you can get into a degradation loop where you are not going to be generating useful data if you are just working on the input that was generated by another AI. But yes, you can use it in part to help with automation. So yes, there are some use cases for that. All right, and I think we got to the end now. So yes, thank you all for coming and for attending, and I hope that this was maybe a bit inspiring to you. And if you're interested in more of this, then yes, of course, if you continue this conversation on the 18th of March and here. As mentioned before by Linda, if anyone has any further questions, feel free to contact her through the email address presented, and the recording of this webinar will also be eventually published for later review. So yes, thank you all for coming, and well, have a nice rest of the day, and hopefully you will encounter no problems whatsoever when you're using generative AI in the future.